All right, next we're going to look at hyperbolas. And here is what the graph of a hyperbola looks like. Right in between you have the center. The center is not actually a point on the graph. All right, and then directly in line with the center and in the middle of those arcs, we have what we call in this graph the vertex. So there are two vertices here. And then just out on the inside of the arc right here, not actually technically on the graph, not on the line, we have the foci. And then the line that goes through all of those points is called the transverse axis. All right, now we also have some asymptotes here, and you have one asymptote that goes through the center like this, and so your graph up here would be getting closer and closer and closer to that asymptote. And then we have another asymptote that makes the other side of the X right here. So when we work with hyperbolas, we're going to be finding all of that information. All right, so the first situation that we're going to consider is this situation, what we just drew. And the equation for this situation is going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. So these equations are going to look very similar to an ellipse, but they're different because they have a subtraction sign in the middle of them. All right, so when we look at the graph, in the middle we have the center, which is hk, and then the distance from the center to each little arc. On this one, since the arc is going to the left and the right, it's going to be a length of a. In a minute, we'll talk about if the arcs go up and down, and then those would be a length of b away. So length of a for this one, because we're talking about left and right, so we're going to be looking at this piece right here. So if we want to find each of the vertices, sorry, I'm going to go ahead and write center HK. And then for our vertices, we're going off of the center, and we're going a distance of a away from the center. So h minus a, k, h plus a, k. Just like last time, we're going to find the foci, and by last time I mean like when we had the ellipse graphs that we were looking at. So again, we're going to have this value of c, and the c value is from the center all the way to the foci. And the way that we solve for c is we do c squared equals a squared plus b squared. So once you solve for c, then you can find your foci. And you go a distance of c from the center. So h minus c k, h plus c k. All right, this graph, the transverse axis is going to be the equation of a horizontal line, and it's going to be the value that goes through k. Well, it goes through hk, but the k value is what's important since we're talking about a horizontal line. So the transverse axis is y equals k. And then the way that we find the asymptotes is we write y take away k equals, the number underneath y is a b, so we're going to do like rise over run kind of, so it'll be b divided by a is kind of the slope. So we'll do b over a times x minus h. That will be one of the asymptotes, and then the other one is just the negative version of that. All right, for the next picture, the graph will look like this. And the equation will look different because this time the y will come first, and that's how you'll know. All right, so that should be a squared. And this time they don't switch the a and the b. They don't say that the b always has to be underneath y. They just put the a there. And ultimately, I don't really care what letter you use, but if we do problems out of the book, they consistently put a underneath the first piece, whether it's an x or a y. So just make notice of that. Okay, so in this case, again, we have the center of our graph is hk, so that makes sense. And this time our vertices are moving up and down, and they're moving up and down an amount that corresponds with the y value. And so because we're using a in our equation, this would be a length of a. So I'm going to say that my vertices are going to be the center moving up a value of a and down a value of a. All right, for the foci, again, we're going to describe this distance from the center as a length of c. And the nice thing is on this one, the c squared is found the same way as the other version, which is nice since in an ellipse it's a little different in each case. In this case, it's the same, so that's helpful. And then this time, the focus is again moving up and down from the center. So I'll say h, k minus c, h, k plus c. And I just noticed I wrote this wrong. Make sure that's one of them is a plus and a minus if you copied me and did it wrong as well. My bad. All right, and then we also have to write down the transverse axis. So in this case, it's a vertical axis. So the transverse axis would be an x equals equation. It goes through the center, so it should be x equals h. And then last, we're going to look at our asymptotes. So again, we're going to start off with y minus k. And then for our slope, we're still going to do rise over run. So the letter that goes with y this time is a, and then b goes with x. So we'll say a over b for rise over run. And we also have to do the negative version of that. All right, let's do an example problem. So this problem says graph and find the foci, vertices, asymptotes, and transverse axis for, and the equation that we are looking at is x minus 2 squared over 16 minus y plus 3 squared over 4 equals 1. All right, so to start off, we know that we are doing the case where it's going to go to the left and the right because the x value comes first. So since it starts with x, we're going to go to the left and the right. And for us to be able to graph this, it is helpful to know what the center is first. So here I know that my center is 2, -3. That's going to help us get started. And it's also helpful to know where the asymptotes are because if we can draw in those dotted lines, then we know that our curves will follow those dotted lines. So we always start off with the y minus k piece of the graph, which was y plus 3 in this case. So for my asymptotes, I'm going to start off with y plus 3. And then the fraction I'm going to put in front is the value of b divided by the value of a. In this case, or sorry, a divided by b. No, b divided by a. That was silly of me. The rise divided by the run, basically. Now be careful because remember this is b squared and this is a squared. So if b is 4, b squared is 4, then b is 2. If a squared is 16, then a is 4. So I have 2 over 4 times, and then I'm going to go ahead and do my x minus h piece, which is x minus 2. And I also am going to have to do the alternate version of that. So y plus 3 equals negative 2/4 x minus 2. Okay, so for the first one, I just want to simplify it so that it's something I can graph. I went ahead and simplified that fraction. So I've got 1/2 x minus 1. And then I want to get the 3 all alone so that that's something I can graph. Subtract 3 and negative 4. Okay, and then I'll go ahead and do the other one as well. So I'll distribute that negative 1/2 minus the 3 over so that I can graph it. Okay, so the things that I'm going to use to start my graph are these two asymptotes in the center. All right, I went ahead and cheated and I just drew them out. So you can take a moment. You don't have to draw a perfect graph in your notes, but if you draw a little sketch, that would be helpful. So we have our center, we have our asymptotes. So now let's look back at our equation. So we're drawing the pieces of the graph that go to the left and to the right. We need to know what the value is underneath here. So our A value was 4, and that tells us how far from the center we're going to go to the left and to the right. So I'm going to go to the right 4, to the left 4, and then I can go ahead and draw my arcs in there. So I know they would hit each vertex, and I know that they would go along the asymptotes. And so I can go ahead and write down what my vertices are now, because I can see in the picture, and if you didn't have perfect graph paper, you could just take your center and move left 4 and right 4. So since my center was 2, negative 3, to the left 4 would be negative 2, negative 3. To the right 4 would be 6, negative 3. And then to find my focus, or my foci, I need to just go ahead and do c squared equals a squared plus b squared. So c squared equals 16 plus 4. So c squared equals 20. I'm going to square root both sides. So c equals the square root of 20. Anytime you see a square root, we've learned how to simplify those before, so we need to do that now. Always simplify them. So I'm going to do a factor tree. That's how I prefer to simplify. So my c value is 2 square root 5. So that means for me to write my foci, I just need to go to the left that amount and to the right that amount from the center. So my foci from the center, it was 2, negative 3. So I'm going to say 2 plus, what was it, 2 square root 5? Yep. 2 plus 2 square root 5, negative 3. And 2 minus 2 square root 5, negative 3. Again, I'm not plugging this into a calculator to find the decimal. I'm keeping my numbers nice and perfect. That's the accurate number, not the approximate number, no rounding. And then I need to find the transverse axis, which is that horizontal line that goes through all those points. And so that horizontal line would be the equation y equals negative 3.